Welcome everyone. We are going to explore the question of what is GIS. As you probably know, GIS stands for Geographic Information Systems, and it essentially refers to three integrated elements. It refers to geography, the spatial reality of what you actually see on the Earth's surface and on the ground. It refers to information that is attached to that geography in the form of databases, and it also refers to the support infrastructure, the systems that are used to do the analysis of geographic information. These three elements together is what forms a geographic information system. And if you look at this image on the right, what we're looking at is an aerial photo of a particular town with parcel data overlaid on top of it. Parcel data are the property lines for the various locations. If we look behind the scenes on this, we can see that each one of these parcels is linked to a database. So when we click on that particular parcel, we learn more information about it. So you can see how the geography and the information are linked in a geographic information system. As we move through the course, we are really going to be embracing this definition that you see here of geographic information systems, because we are going to learn how to utilize GIS to collect data, and we are going to utilize it to manage and edit data and maps. We're going to learn how to analyze and model geographic data to get answers that we need to resolve particular questions that we might be asking, and then we're going to learn how to present our results in a form of a map or web-based visualization. When I talk about GIS to individuals, I like to put it in terms that is a little bit easier to understand than that wordy definition that we saw on the slide previous. I like to call GIS smart maps because of the fact that you can link a database to a map, and it allows you then to ask your map questions and get fast, accurate answers back. So GIS is much better than a static map that you might be looking at, is because it's interactive, changeable, and dynamic. If you want to analyze data, you can add more data layers to it so that you can ask your map more complicated questions. And one of the key concepts in GIS is that it's comprised of different layers of information. What is the big deal about GIS in my mind is the fact that you can ask your map questions and get fast, accurate answers back. So let's say that we have a question, we want to know which properties in Lebanon County were affected by a recent flood. If we have the parcel data and the boundary of the recent flood, we can do an overlay to see which ones were impacted. We can also look at how many industrial sites are within a quarter mile of I-78. So those are some types of questions that can be asked of your data. You can also ask questions based on attributes, which townships in Lebanon County have more than 5,000 people, and how many Lebanon County parcels are in ag security. So let's look at this on a map so we can see how this actually plays out. So this particular map that you're looking at right now is a map of Lebanon County townships. And what's unique about this map, while it does not look very impressive at this moment, there is a lot that we can do with this in GIS. If we go and explore this particular data set, if we right click on it, we can open what's called the data's attribute table. And this attribute table stores information about each one of the Lebanon County townships. We can see that it has the municipality name in there. If we keep scrolling over, you can see some other information. Some of it may not mean as much as some others, but here we have a field that gives the median household income of the township. This one gives the total population. As we keep scrolling to the right, we see that we have the ethnicity breakdown in each of the townships. We have age breakdown, and so on and so forth. So there's a lot of really good information associated with the townships that we're seeing here in Lebanon County. Now this means two really big things. It means because we have that table, we can make maps based on those attributes that reside in that table, or we can ask our maps questions based on that data. So for this particular one, I want to know how many townships have a median household income of greater than $70,000. So what I'm going to be doing, and which you'll learn how to do later in this course, I'm going to do what's called a query. I'm going to ask my map that question. So I scroll down to my the field that I'm asking the question of, and is greater than 60,000. And when I hit OK, those townships that meet that criteria are selected. So you get that answer really quickly. And if we want to know how many and which ones meet that criteria, we can go back to that table that we just were in, and you can see that all the ones that are selected on the map are also selected in the database. So one of the key things with GIS, if it's selected on the map, it's automatically selected in the database, and vice versa. If you select something in the table, it will then be selected on the map. If we want to just limit this to the townships that meet the criteria, we can just show the selected. And then another really neat thing that we can do here is we can put them in ascending or descending order, from most to least or least to most. And I'm just going to do it ascending, where you now can see, you know, the one that's just right over 60,000 is first, and the highest one is last. And if we go and look at the table, we can see out of all the townships in Lebanon County, South Londonderry Township has the highest median income. So again, we can ask our maps questions based on those attributes. Another thing we can do in terms of asking our data questions, we can ask questions based on proximity, the relationship between features to other features. And it's called what's called a proximity relationship. But let's go down to this particular example. And what we're looking at here, while it might look a little bit messy, what we are looking at are the Lebanon County townships again, road center lines, and bridges. To make this a little bit easier on the eye, I'm just going to turn off my data layer of road center lines so I can see the map just a little bit better. Now, what I want to ask my map is how many bridges are in a particular township. So let's say that we want to know how many bridges are in this township, in Bethel Township. We can actually select that township using one of our tools that you'll learn how to use in the next module. And then we can go to our selection menu, go to select by location, and I want to select features from bridges that intersect the selected features of Lebanon townships. When I hit OK, only those bridges within this particular Bethel Township are selected. And then if I go to my attribute table of bridges and open it up, down at the bottom here, I can see that there are 39 out of over 37,000 bridges in Pennsylvania. 39 of them are located within Bethel Township. So again, that's asking a question based on geographic relationships from one feature to another feature. The other very important concept in GIS with the attribute tables is the fact that not only can we ask questions of our maps based on this information, but we can actually design and create maps based on that information. So I'm going to go up here to this particular example, and this is showing Lebanon County parcels, and parcels are all the properties in the township. And this data is probably one of the key data layers in any municipality GIS, because it has so much information in there that can help you make important decisions. If we open up the attribute table of this parcel data, we can see that we have the PIN number of the property, how many acres the property is, where it's located. If we keep scrolling, we can see that we have the actual landowner name, we have that person's mailing address, and so on. But one of the particular fields that is available in this table is whether or not the property is in an ag security area. So we want to make a map that shows which ones are in ag security and which aren't. So to do this, we just will go to our layer properties and create a map based on that particular field, and all these things that are listed here are actual fields in that table that we were just looking at. I'm going to scroll until I see ag security and then hit add all values. And the N means no, the Y means yes, and the empty one means unknown. So I'm going to change these values just to make it clear so we're not using any codes. And this is going to become important when we get into map design, because your as a map designer, your job is to make a map that anybody can understand. If you use codes, that oftentimes is not understandable, but only to experts in that particular area. So you have to be careful in terms of making sure that you spell out what you are actually trying to show. And because I want, I'm just going to quickly change the order of these to put the more important ones on top. And you can change the colors. I'm just going to opt to keep them matte. But once I hit OK, notice now I have a different map. What is being shown are the parcels that are in ag security, and those are not. So very quickly you can see where ag security areas might be concentrated and where they aren't as concentrated. And if we wanted to, we could even just come up and add our townships and just hollow that out. And so we can see the actual township boundaries on top of this map, which makes it a little bit more meaningful, since we know we can see then more of an idea of how many are within each township. But again, the key piece of GIS is the fact that you have that database that's linked to geographic information. And because of that linkage, it gives you a lot of power to do different types of analysis and ask your data questions and get fast, accurate answers back. But your answers can only be as good as the data that's feeding this, and that's something that's going to become important. One of the things with this parcel data, if we take a look at it, let's say that we want to select all preserved farms in Lebanon Township. Take a look at what happens when I do this. So ag preserved is equal to, and notice I get 3 different values that come up for preserved, and that's problematic because what's happened is it was spelled incorrectly at some point in one of them, so it's not showing up as in that same category, and they used a different coding system for this one. So that is one of the problems with tables, is that there needs to be consistency in spelling and so forth, or you're going to actually see things come up as different values. As we move through the course, you're going to learn how to add values to that attribute table to add additional information, and you're also going to learn how to edit it to fix any mistakes that you might find or that you might have even made yourself. So as you can see, GIS allows us to interact with the data on our map. And each one of these features that we see on our map is linked to that database. So if I just wanted to say, for instance, in this case, find out a little bit more information about Blair County, I can select it, and it gives me the information for that particular item. So there's lots of different ways to access the attributes of the various data layers that you see on your map. So one thing that I like to dispel in the very beginning is that GIS isn't just about making maps and producing maps. It's so much more than that. To me, it's about the analysis and the answers that you can get very quickly about geographic information. And the fact that it allows you to interact with the data and ask questions is something that is key. The map is usually the end result of the analysis that you conduct. So as you can see, GIS allows for data visualization. You probably have a lot of data in spreadsheets and databases, and when you look at that data, it doesn't necessarily resonate as well as a visualization does, because a picture is worth 1,000 words, and that adage is really true with a map, that, you know, we're looking at this map here and we're looking at population. Seeing this map, we can see distribution a lot easier than we can see in this table. This is the same data, just presented in different ways. We're looking at 2,000 population on this map, and in here you're just seeing a list of values. This probably has a little bit more meaning to us, and it helps us to look at patterns more deeply, look at trends, and just see how various features might be related. With GIS, it's not just about making maps, but it's combining various display methods to have a bigger understanding of the topic at hand. The example that I have here is looking at geologic hazards in Pennsylvania. While we have maps that show the distribution of where the sinkhole-prone areas are, where the earthquake epicenters are, the landslide susceptibility, you can see those, the geography of it, but then you can also add images and text that help even better clarify the message that you're trying to communicate about the particular topic of your map. And you'll find later that not only can we add images, text, and so forth, we can add graphs, charts, and other information that to our maps, so that we can make more meaningful outputs, so that we can better understand the topic that we are discussing. So one of the key things with GIS then becomes the data layers. As you can see in the maps that I was showing you, that all the data layers would overlay on top of one another, and that's just because they all have a geographic coordinate system assigned to them, so they know how to overlay on the map. And some of the more common data layers are shown here, but there's parcels, land use, roads, streams, and so forth. So you can't really do anything with just having a software program. What you really need is data to support that software program. And that is going to be one of the biggest takeaways that you will get with this course, is where does data come from, and how can we create it. You're going to learn how to use online GIS clearinghouses. You can collect data with GPS units and integrate that into your GIS. You can create your own data by digitizing various maps. You can purchase it through a particular vendor. A very popular way of getting data is sharing with your colleagues. For instance, if you work for the Planning Commission, you might be sharing your zoning data and comprehensive plan data with various municipalities, so that they can also be using the same data set, so that you're all operating on with a common operating picture. There's remote sensing data, and you'll learn how to find aerial photographs and satellite imagery that might support your particular task that you're working on. Even you're going to find that Excel spreadsheets and databases can often be integrated into GIS. So there's a lot of different ways that you can get data into GIS, and again, we'll be learning those various methods and sources of GIS data throughout the course. So to end things with, I want to talk about the type of questions that GIS can answer, just so you're thinking of what you might be able to do with GIS in your particular area. GIS can answer such simple questions as, what is there? Let's say that there is a project being proposed at a particular site, and you want to know, well, what are the conditions like at that particular site? You can get an aerial photo so that you can see what it looks like. You can download soils data to see what the soils are like. You can get a digital elevation model to see what the slope of the property is like. You can download wetlands information to see if there's any wetlands in the area. So just a very basic question that GIS can answer is just, what's there? And that's probably the most common question in GIS. But we can also ask questions based on condition. So for example, maybe you want to know what Lebanon County municipalities have a median income of greater than 40,000. That's a specific condition, and you can make those even more complex. You can add to it, like which ones have a median income of greater than $40,000 and have more than 50 ag security areas in it. So you can just keep adding those conditions to that to get an answer. One of my favorite things to look at are trends, what has changed over time. Like if you want to see how a particular area or township has changed, you can get aerial photos from previous surveys and look at that change over time. One of the great sources for Pennsylvania is the Penn Pilot program that has historical aerial photos from 3 different eras, and then you can be looking at those in conjunction with ones that we're taking more currently to see how things have indeed changed. We can look at different patterns, and this is one I had here from my days working with the Park Service. How does a campsite's proximity to a salmon stream affect the number of bear attacks? This was happening out in Washington State, where they were having an increased number of bear attacks at a couple of particular campsites, and they just want to see what the correlation between the campsite's location to the number of bear attacks. And then finally, you can do what if scenarios, like what if we did this, what would this actually look like on the ground? Like what if we enacted certain zoning ordinances, how would that impact the development of the township? So as you're moving through the course, think about the questions that you want to ask and what kinds of things are important to you and your area. When you keeping these questions in mind that GIS can answer, will help you better craft the project that you're working on.